Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You're most welcome for today's lesson. As always, I'm Teacher Scovia, your chemistry teacher. You're most welcome for this lesson. So, you remember in the previous lesson, we had started looking at, or we had looked at some of the nitrogen compounds, right? Nitrogen compound, we had discussed about nitrogen dioxide. We had looked at its preparation, its uses, properties, all right? So we are continuing to look at some of the inorganic compounds of nitrogen. Today, we are going to look at ammonia, all right? We are looking at ammonia. So we are going to look at the preparation, all right, of ammonia, properties of ammonia, both physical and chemical properties of ammonia, and we are looking at the uses of ammonia. It's our lesson today. So we are looking at preparation, properties, and uses of ammonia as among the nitrogen compounds or the inorganic compounds of nitrogen. So what is the objective of the lesson? The objective of the lesson, by the end of this lesson, all learners here, I expect you to be able to describe the laboratory preparation of ammonia, to describe the properties of ammonia, and to state its uses, or the uses of ammonia. So, get ready with your books, with your pens, and be attentive for the lesson, so that at the end of this lesson, everybody among you there should be able to describe or to attain this objective. All right? So we can start off. So we start by looking at the laboratory preparation of ammonia. Look on the slide there. The laboratory preparation of ammonia. All right? So we can prepare ammonia by reacting. These are the reagents we use. The reagents we use, there is calcium hydroxide and ammonium chloride. All right? Calcium hydroxide and ammonium chloride. Those are the reagents we should be having in the lab. So when we react calcium hydroxide with ammonium chloride, we get calcium chloride, water, and ammonia gas. So as I always tell you, in the preparation of substances in the lab, there are things you need to put into considerations. You need to know the diagram, how to draw the diagram. This is the diagram, how it is set up. So it is a round-bottomed flask. This is a electrode stand, held on a electrode stand, connected with there is this substance inside here. The substance is calcium oxide. The role of this calcium oxide is to dry. Since we have some water there, this ammonia can go or is expected to be moving with some water vapor. So it is retained here. All right? So as calcium hydroxide reacts with ammonium chloride, we form calcium chloride and water and ammonia gas. So this water is retained within the substance A, which is calcium oxide. So ammonia is collected as a dry gas. All right? It is collected as a dry gas. Here we put some emphasis that normally I've been seeing in other preparations saying that sulfuric acid is a drying agent. But for this case, sulfuric acid and anhydrous calcium chloride are not used as drying agent. Do you know why? The reason is concentrated sulfuric acid and this anhydrous calcium chloride react with ammonia, right? They react with ammonia, so they cannot be used as drying agent. Normally, a drying agent is not supposed to react with the substance produced. If they would react, then it would not be efficient. So that's why we use calcium oxide, which does not react with ammonia, as a drying agent. You need to know that. In an exam, you can be asked one day, why is it that concentrated sulfuric acid is not preferred to be used as a drying agent in the preparation of ammonia gas? You will say, what will you say? You will say, since concentrated sulfuric acid reacts with ammonia, it cannot be used as a drying agent. All right? Good. So that is the diagram. The equation is there. So what are we remaining with? What kind of collection is this? What kind of collection is this? This is the gas jar. Who can tell us? This is very simple. Just look at where the delivery tube is pointing. It is collected by upward delivery. Say upward delivery. Whenever this is pointing up like this, you get no, it is upward delivery. When it is pointing downwards, you need to know it is downward delivery. And you should always remember to know the reasons, or why is it collected by upward delivery, why is it collected downward delivery, or why is it collected over water. I always emphasize on those things. We don't just guess that it is upward delivery, it is downward delivery without giving a reason. We should give a reason why it is upward delivery. So it is upward delivery since ammonia is less dense than air. Something which is less dense just fronts. If you need to get it, you get it on top, up. Very simple for you, all right? Something which is less dense always is on top, fronts. So if it fronts, we expect it to be up and is collected upward. Very simple for you. Something which is more dense, we expect it to be down. That's why the delivery tube would face downward. All right? Good. So the confirmatory test. How will you tell? How will you tell that the gas that I've prepared is ammonia gas? Confirmatory test. So when ammonia reacts, you introduce in hydrogen chloride gas. Hydrogen chloride gas. When a dense white film is formed, you get to know that is ammonia gas. Because ammonia gas, when introduced with hydrogen chloride gas, you get ammonium chloride solid. A white dense film is formed. Right? So that is the confirmatory test of ammonia gas. So those are very important things you need to note on preparation of substances. You need to know the diagram, I always emphasize that. You need to know the equation of reaction for the reagents that are involved. You need to know how the gas is collected, the method of collection, and the reason why is that method preferred. And then the confirmatory test. How sure are you that the gas you have collected is ammonia? So there are some reagents that are used to confirm which gas is this, which gas is this. So for the case of ammonia, it's hydrogen chloride gas, whereby when it reacts with ammonia gas, you get ammonium chloride, which is a white dense film. You just say white dense film, which is formed. Isn't it? Good. So the properties of ammonia, the physical properties of ammonia. So ammonia is a colorless gas. When it is produced, it's just a colorless gas. It has a pungent choking smell. When you bypass the laboratory and somebody is working with ammonia, everybody will tell. We know that this is ammonia exactly, because it has that smell of a rotten egg, that choking smell. So you wouldn't like it. You wouldn't like it. So another property of ammonia, it is very soluble in water. That's why we cannot collect it over water, by the way. We cannot collect ammonia over water since it dissolves in water. All right? Good. So what are some of the chemical properties of ammonia gas? So I said when we talk of physical properties, we also need to talk of the chemical properties. One, combustion. Ammonia does not burn in air, neither does it support combustion. Effect on the litmus paper. Effect on the litmus paper. Ammonia turns most red litmus paper blue. It is the common alkaline gas. We have talked of nitrogen dioxide being an acidic gas. For the case of ammonia, it is the basic gas. It's an alkaline gas. It turns a wet red litmus paper blue. To remember that bases or alkaline turn blue litmus paper red. So the case for ammonia. So when you introduce a wet red litmus paper in a gas jar where there is ammonia, it will immediately turn blue. All right? So reaction with hydrogen chloride. As I said earlier, hydrogen chloride gas is the confirmatory test for ammonia. So whenever you react ammonia gas with hydrogen chloride gas, we expect to form a dense white fume, which is ammonium chloride. Right? Ammonia gas plus hydrogen chloride gas, you get a white dense fume of ammonium chloride. Right? Solid. This is a white dense fumes. So it is the confirmatory test of ammonia gas. All right? Good. Another thing we need to look under ammonia gas, we can also manufacture ammonia by what we call Haber process. All right? So after looking at the laboratory preparation of ammonia, after looking at the physical and chemical properties of ammonia, there is another way, excuse me, on how we can prepare ammonia by what we call Haber process. Haber process. So here, another way to another way to manufacture ammonia is Haber process. The Haber process. So in Haber process, there are things we need to be having. Those are raw materials. The raw materials we're supposed to be having are majorly two. That is nitrogen and hydrogen. Nitrogen and hydrogen. Hydrogen. These are the raw materials. But there are conditions also we have to work in. All right? So there are raw materials and conditions. What are the conditions? The conditions 1. Nitrogen and hydrogen should be in a ratio of 1 to 3 volume. That is, nitrogen and hydrogen should be in a ratio of 1 to 3. All right? Then this is 1 to 3 by volume. Then there is a pressure we need. We need atmospheric pressure, or we need an atmosphere of, between atmosphere, pressure, need pressure of around 200 to 250 atmosphere. All right? We need temperature of between 400, temperature of between 400 to 500 degrees Celsius. We need a catalyst, iron catalyst. All right? We need a catalyst here. A catalyst, what is the role of a catalyst? What is the role of a catalyst? Aluminium oxide. Iron impregnated with aluminium oxide. What is the role of a catalyst? To speed up the reaction. But it remains unchanged at the end of the reaction. So that is the raw material, the conditions we should be having in the manufacture of ammonia under Haber process. So the reaction that takes place, the equation of reaction. So look on the slide. When nitrogen and hydrogen react under the conditions we have mentioned, what are those conditions? Presence of nitrogen and hydrogen, pressure of 200, 250 atmosphere, temperature of 400, 500 degrees Celsius, and a catalyst, aluminium oxide. When they are available, these conditions, and the nitrogen in the ratio of 1 to 3, the reaction forms, or we get nitrogen with hydrogen to get ammonia gas and some heat. This is exothermic. The reaction is exothermic. It means some temperature is given out. Some heat is given out. It is exothermic. You remember we have two kinds of reactions, exothermic and endothermic. Exothermic, this is a kind of reaction which gives out heat, but with endothermic, it retains heat. All right? So this reaction is exothermic since it gives out heat. So this is the diagram for what we have talked about. This is the Haber process we have been talking about. So you see nitrogen, you remember it should be in a ratio of 1 to 3. 1 nitrogen, hydrogen 3. So it is put in a compressor. It meets the catalyst base. There is aluminium oxide here to speed up the reaction. All right? Temperature should be available. That is 400, 500. So as they react, this is the heat exchanger. It goes, those that are not reacted, those that are the nitrogen and hydrogen which have not reacted, unreacted hydrogen and the nitrogen should go back, recycled, you see. So there is water supply here, cold water supply, to cool or to condense the gas, right? So this liquid ammonia is formed here. So because it comes in the form of a vapor, it is cooled down here in a condenser. This is a labor condenser, which is used to condense supplied with cold water. When the water gets hot, it is liberated out through this outlet, hot water. So it is supplied when it is cold. It tries to condense this gas here, ammonia gas, which is formed. Right? As it condenses it, when the water becomes hot, it is given out, more cold water comes in. All right? So the unreacted nitrogen and hydrogen will be recycled, will be taken back for more to be reacted again, or to be worked upon again. All right? So this is the Haber process that is used in the manufacture of ammonia. This one gives or liberates ammonia in abundance than in the other lab preparation of ammonia, which just gives around 10% of ammonia. This one will give abundant of ammonia, or enough ammonia, than the first one you have been looking at. All right? Good. So after knowing that, after I've seen on the preparation of ammonia using the Haber process, we can go ahead and look at the uses of ammonia now. So why do we need to manufacture ammonia? Why? Why is it, what importance is ammonia in everyday life? One, ammonia is used on the large scale as to make fertilizers. All right? So it is used to make fertilizers. So ammonia is used in the manufacture of nitric acid. It is used in refrigerator in a large scale, refrigerating plants and factories. It is also used as a solvent during cleaning in laundries, washing, and they're washing clothes. It can be used as a solvent, right? So ammonia is also used in the manufacture of ammonium salts, such as ammonium chloride, which is used in dry salts, and ammonium carbonate used in smelling salts. All right? So ammonia can also be used in manufacture of dyes, wood pulp, plastics, and fibers, such as nylon. All right? So from there, after we have learned the uses of ammonia, you have to always, when you are here in class, you should always continue to put in your mind the objective of the lesson. All right? The reason to why, what is the major thing you have to come out with the lesson of today? You remember, when we were starting the lesson, we had said that at the end of this lesson, you should be able to tell the preparation of ammonia. You should be able to tell the properties of ammonia, that's both physical and chemical properties. You should be able to tell the uses of ammonia, and you should be able to describe all those methods that are used in the manufacture of ammonia, Haber process inclusive. All right? So in the Haber process, that's why I've put emphasis that abundance of ammonia, or there is manufacture of ammonia in abundance when we use Haber process than this first reaction, this first method where we react calcium hydroxide with ammonium chloride. All right? I think the lesson has been interesting. Do you have any question there on the objective or on the things you have talked about on ammonia? I think everybody can answer any question that may arise on ammonia. So let me review with some questions. So when you reach home, you try to attempt these questions on ammonia. It's one question, but having some subtopics. So it's here. I don't have to read it for you, but I see it includes what we have talked about. It's majorly talking about the Haber process. All right? It's talking about the Haber process. So in the Haber process, we said we use nitrogen and hydrogen in the ratio of 1, nitrogen and ammonia 3. I mean in hydrogen 3, in the ratio of 1 to 3. We get ammonia here. All right? So you use this equation. You use this equation here to answer these questions here. One, ammonia is made out of many atoms. How many hydrogen atoms are there in ammonia molecule? How many nitrogen atoms are there in ammonia molecule? What is the most common use of ammonia? Who invented the Haber process? What does the Haber process produce? What type of catalyst is used in the Haber process? What happens to the unreacted hydrogen and nitrogen? We talked about that. What is the ratio? I talked about that. Of nitrogen to hydrogen by volume. Is it three volumes of hydrogen, 3 volumes of nitrogen? So you need to tell that because we have looked at that together here. So thank you so much for today's lesson. I think it has been very interesting because you have been following. I've been seeing you following there. So I'll try to attempt those questions. When we come back, we shall try to collect them together here. Thanks so much. Nice time. Enjoy your day.